So today I will be going over the basic knowledge of the agricultural drone. This will include the introduction, the flight control system, propulsion system, link system, and spraying system. So within the multi-rotor drone concept, this flying platform is used for crop and plant protection within the agricultural system. So it is used for spraying and spreading, and this can be fertilizer, pesticide, pollen, seeds, and even food for fish, and it's operated with the remote controller. DJI has a concise mechanical structure, vertical takeoff, landing, and hovering capabilities, and it is fairly easy to operate. Within the family of agricultural drones, we begin in 2015 with the MG series. Then in 2017, the P4 series is introduced, leading to 2018, where the T16 is introduced. And in 2020, the T30 and the T10 were the final products to be introduced. In terms of the structure of the drone, there is the motor, which powers the system, the ESC, which drives the motor. The propeller is used for lift. The nozzle nebulizes the liquid. There is a pressure relief valve that can be opened to release air when spraying is not occurring. The arms are part of the body. The landing gear holds the entire body load, and radar detects changes in terrain, helps confirm the altitude, and supports obstacle avoidance. The camera transmits video to the remote controller. Again, that's helpful in obstacle avoidance and terrain features. The LED light illuminates surroundings at night. Your spray tank contains the pesticides, and the water pump produces pressure for the pesticides to move through the entire system. When it comes to the T30 and T10 motor systems, on the slide, CW means clockwise and CCW means counterclockwise. The numbering system for the entire drone goes in a counterclockwise fashion, starting with number 1, 2, and 3, and so on. So for the T30, motors 1, 3, and 6 rotate counterclockwise, and motors 2, 4, and 5 rotate clockwise. On the T10, motors 1 and 3 rotate counterclockwise, and 2 and 4 rotate clockwise. It is important to remember that each motor's angle is different, and these fixed angles cannot be changed within the system. On your remote controller, there is a back button, a return to home button, which can be used when there are no obstacles in the field, power, a confirm button, 5D, flight switch mode, which can switch between P and A, and button C3, which can be assigned. You have your spray dial, your antennas, the HDMI port, which can be used to plug into the projector and can help with running the simulator for when you can't go outside and you have to train. A reserved dial, a USDA port, the FPV map and switch button, micro SD card slot, and spray button. When it comes to the remote controller, there are 2 different modes. There is mode 2, where the accelerator is on your left-hand side, and mode 1, where the accelerator is on the right-hand side. Most of the time, people will operate using mode 2, but you just want to confirm that it is set up that way, especially if you have a new drone that you are using. So moving on to the flight control system. So when you're inputting information into your flight control system, There is communication between the remote controller and ground station. That information is then run through the main controller, which consists of the compass, radar, IMU, and GNSS. So think about this as like the brain of the entire system. And the order that this is executed is through the ESC. So within the main controller of the flight control system, the brain, there is the CPU of the aircraft that executes the movements. Within that CPU, there is the GNSS, which provides your latitude and longitude, your compass, which helps provide direction, your IMU, which provides the aircraft's attitude, and the radar, which again perceives changes in altitude and movement and helps with obstacle avoidance. So with the radar, you have the two main functions, the altitude detection. So this also helps stabilize the altitude to follow the shape of the landscape, and obstacle avoidance, which detects obstacles to avoid collision. Moving to number 3, your propulsion system. So you have your power supply, which is your lithium battery that is charged. The battery, along with the master control, which involves rotating speed, are then together input into the electronic circuit. This circuit then drives the power output to the brushless motor, which then powers the propellers, which is the source of lift for your agricultural drone. So previously I mentioned the difference between counterclockwise and clockwise propellers. So both of these have markings on them to indicate which one is which, and the direction of the propeller should always be in accordance with that of the motor, or else your drone isn't going to be able to take off. Moving to number 4, your link system. So within your link system, there is the ground unit, which sends control to your aerial unit, which is the drone. The aerial unit sends its status back to the ground unit. So it first starts with the mission control to receiving control, and then data transmission to data reception, and video transmission to video reception. Moving on to unfolding the antenna. The antenna must be unfolded. If folded, the transmitting efficiency and distance will be affected. The antenna cannot point toward the multi-rotor drone. The signal at the top and bottom of the antenna is the worst. The antenna should be parallel to the drone. When the remote controller is in hand, the antenna points toward the sky. So 5, your spraying system. So with your spraying system, you load the pesticide into the spray tank. There is filtering that occurs through the filter. Your pressure output is a result of the water pump, leading to nebulization, and the nozzle and pressure relief valve are also used in that process as an exit. The pressure spray system has a strong penetrability and is corrosion resistant. The nozzle is easy to clean and replace, and it's always better to choose a water-based pesticide versus a powder-based pesticide due to clogging in the nozzles. Monitoring equipment. So the flow meter calculates the pesticides to help plan the dose more accordingly, so it essentially regulates how much pesticide is moving through the system. Your liquid level meter indicates the remaining pesticide and warns when it is nearly empty. Your nozzle. So the pesticide is enabled by the pressure of the water pump, atomized by the nozzle, and then sprayed. The pressure relief valve helps empty the air for the spraying system. And lastly, on nozzles, this chart indicates your nozzle model, your mesh number, the nebulization pressure, the nebulization angle, the droplet size. F is fine, M is medium, and VF is very fine. And the single nozzle flow rate is in liters per minute on the right-hand side. The standard nozzle for the DJI Agras is XR11001VS. So it's a 110 degrees scalloped stainless steel nozzle.